I've been wanting to test the difference between a convex edge versus a certain type of straight edge. Basically, it's pretty popular in the knife world to put a convex edge on a blade because of the benefits that it has. Basically, though, one of the things that I've heard from people is that if you take, say, a factory V-edge and you grind it down to a convex, that it's actually going to have better edge retention. And I'm not really sure if that's actually true. But basically, this is how I've seen it explained. So let's say you have a V-edge. So let's draw that up. Okay. So it's going to draw V-edge. So basically the belief is that if you were to grind your shoulders off and turn this into a convex, so let's just, I'm just kind of trying to approximate it here. But what the idea is that our apex angle will stay the same, but we'll remove our shoulders. So try to keep that roughly the same. So here we have this now convex edge instead of a straight V-edge. But yet the idea is that here at the tip, our apex angle is still the same. Now keep in mind that with a convex edge, there's always going to be a degree of arc. And I would say on a typical convex, it's probably going to be anywhere between like 5 and 15 degrees of arc. But let's say 10 is what most people are probably shooting for. So there's going to be a 10 degree of arc here. But I feel that part of the problem with the convex is that doesn't really translate to much when we're talking on the scale of just your apex here. So what I feel is happening when people find that they grind off their factory edge and convex it results in them having better performance. I think it's two things. First of all, I think that often they're actually reducing their angle. And so they're actually taking, say, their factory edge, and they think that they're keeping it the same, but they're sharpening by hand, so it's not perfectly accurate. And so maybe they're actually reducing the angle to a more obtuse angle than it was. And they just don't realize it. And so now, this was actually a sharper, more acute edge than this. And if that were the case, then yes, you would see perhaps better edge retention. And this is because, really, according to the science, what gives you better edge retention is having more material behind the apex. And essentially, the way you would generally do that is by having a more obtuse angle, a less sharp angle. Now, I think the other reason why people might notice a performance difference may not have to do with this, but it could be a combination of the two, is that by convexing, let's say in the first convex line here, you're removing the shoulder. This steel is all eliminated that was there before. This steel here is all eliminated. And so that's going to result in, when you're cutting into, say, something hard like wood, it's going to more easily slice in because it has to wedge less material out of the way. And that transition between the shoulders is going to be gradual instead of abrupt. You know, you're going to have your secondary bevel here. Your primary grind. Say that this is the primary grind. And so if this arc continues, you know, suddenly with this convex, you have a much thinner profile. You see. And that's not really going to come at the cost of, you know, strength of the blade, because there's plenty of material here. And I think that's why people notice a performance difference. But to kind of explain the theory a little further about convex, let's draw a more pronounced convex in the traditional sense. So we got a kind of a traditional convex here. Sorry, it's not going to be perfect, but so we have our convex here. And how it'll be often explained is, you know, your blade is generally going to be pushed in as it's cutting into the material. But it's going to be subjected to lateral forces, which means forces coming from the side. And so what that means is these forces can be directed sideways and essentially break off your apex, or at least cause it to be damaged, you know, fold over and roll over. But the thought behind the convex is that, you know, the force is pointing inward to kind of a central point, you know, and so it's a stronger configuration. But I don't think this is quite correct, because what I believe is actually simply happening here is that if this were a V-edge, it would be like this. So we got a V-edge here. First of all, this apex here would be more acute. It's at a higher angle, so it's going to take damage more easily. But second of all, you know, like say you're putting this on an axe edge where you're really subjecting it to harsh lateral forces. This is quite a bit more thickness that's gone. This is taking meat off the blade. And I think that is actually where you get your strength from. Having this convex, you know, allows you to have a fairly acute edge and not sacrifice too much, not adding as much material to the blade, because to achieve an apex this wide with a V-edge that's this obtuse, I should say, you know, you'd have to have a V-edge that's doing like that, you know, and that would be crazy on your shoulders. You know, if you're like swinging an axe, how wide do you need to have your shoulders here? And so this allows you to have a thinner shoulder, so it's going to penetrate deeper into whatever you're cutting. But there's another way to achieve this, and that's what I want to test. The other way that you can achieve this, and here I'm just going to draw a little smaller example, is by doing a micro bevel. So what a micro bevel would be is you have a very acute edge. So we'll say, take this to like right here. And then take this. Where's that? Right there. there. And then you do a micro bevel. Now this is exaggerated. You know, I wouldn't do a micro bevel that's this obtuse. But essentially what you're doing here is you are giving yourself less shoulders so you get that better penetration, but you're able to have the apex angle that you want that's more obtuse, that's going to hold up longer. And so what I think is that for most use cases, what you could do, even like say in this one here, is you could take, let's say, this angle here, and then same thing over here. Take this angle right here. Whoops, I took that a little bit too high. And then simply connect it here with a micro bevel. But actually, let's just use this point here as reference because it's a little more easy to visualize. So we'll make a micro bevel here and a micro bevel here. So you'll notice, compared to this convex, which went to this point, this is actually thinner. It actually has less material. Now there will be a little bit of, push this up here a bit. You know, you have your secondary grind that continues on here, you know. I mean, sorry, excuse me, your primary grind, which I think was kind of this line here, whatever. You know, that's going to be, you know, a different angle. But that's not going to be very pronounced of a shoulder or as pronounced of a shoulder. And I think this might, in fact, this might actually slice better than a convex. Now, it does have disadvantages where if you were subjecting it to enough forces where this amount of, like, say, like right here, this amount of material in this thickness area here isn't enough. And so then, you know, you get a chip. That's what I'm kind of drawing here. It's like a chip comes off here and you lose your edge, you know. Well, you just got below your micro bevel in damage. So if you're damaging below your micro bevel, then yeah, you need to have, you know, a more obtuse V-edge angle here, or a convex. But I don't think most people are ever really going to be subjecting their knives to that sort of a use. I think in most scenarios, this is fine. It's only going to be if you're making, like I was making a chopper or an axe or something like that, would I feel that I would need that much more meat on the bone on my shoulders here to have that convex. I hope that makes sense. The only other thing that you can do, which I'm not going to test in this video, is you can actually do what's called faceting. Now, faceting is just where you make multiple flat edges. So say on this edge, we instead, you know, make an extra cut here. You know, an extra cut here. Well, let's draw it in. And then this, you know, is gone. And then you could do another cut here. And another cut here. In a flat line. And you're essentially turning it into a convex edge through flat lines. Sorry, my drawing is terrible. But I'm not going to get into faceting here. But faceting is another way that you could sharpen a convex through only flat edges. And that actually kind of comes down to the whole purpose behind this test, is that sharpening convex edges is difficult for most people. Most people can only do it by hand. And unless you have the skill, it can be really hard to put a really nice edge on a convex when you can just use one of the more modern fixed angle sharpening systems and get it, razor sharp on one of those with flat edges. So what having a micro bevel allows is for you to easily get the performance of convex, but without having to do it by hand, being able to do it on a fixed angled system with straight lines. Now, maybe that's not correct, and maybe convex does have advantages, but that's what I'm going to test, and we'll see. But my theory is that we're going to see similar results between the two. So what I'm going to do for my testing is I'm going to use the same knife, and I'm first going to do a convex on it, and then I'm going to do flat edges, and we're going to do the same testing on each to see how they compare in their edge retention. So I'm going to start by putting a convex edge on an old 01 tool steel knife of mine. I have the TS Prof sharpening system where I kind of created an extra holder for the stone, so it's a holder inside of a holder, so that I can get a little bit of a lower angle on this system without hitting all the parts. I also had to grind away at the holder here too to give it a little bit of a thinner profile so that I can get to lower angles. And then I have the TS Prof convexing attachment. And so what this is going to allow me to do is I can get a convex, and you'll notice how with this setup it has a perfect curvature where I can completely control the angles. So this will allow me to do a more fair test. So the way I have it set up is the lowest angle here, which would be on the shoulder, the upper portion, I'm doing that at 10 degrees. And then the actual apex is at exactly 20. So it's a 10 degree of arc total. And I wanted to do 8 and 18, but it's a little bit hard with this knife because of how thin it is. It doesn't extend out enough. I wanted to do an 8 degree at the lowest angle, but I can only get it to do a 10. As you can see, it's actually pretty close to hitting the arm here. But I'm going to go ahead and sharpen this with convex, and then we'll do some testing. So I got it sharpened. It's got a nice convex on it. I did it to 3000 grit with a 0.5 micron diamond emulsion compound for the stropping. Let's see how sharp it is. It looks pretty good. So the next thing I'll do is some testing. So I was trying to think what would make for a good test for this, and hopefully this works all right. I think that certain tests don't really put your edge geometry to the test. Like if you're just cutting through rope or cardboard, I think that's kind of more testing its abrasion resistance, and it's not really subjecting it to lateral loads. So I think what I want to start with is trying to just slice through hardwood. So this is just a piece of maple. And what I'm going to try to do is use the one side with the one edge geometry and then the other side with the other. And what I'm going to do is I'm going to cut for a couple minutes, and then I'll see how its edge is doing, and I'll keep doing it until I feel that the edge is deteriorated to a certain extent. And so let's go ahead and start our timer, and I'll try to be as consistent as I can in my cuts. Okay, how's a minute and a half? Let's see how it's doing with the phone book paper. Still pretty sharp. I have more of these if I need them. Sheesh. Okay. So let's try paper. Gonna keep going. This time, let's go ahead and try some other tests. So next, let's try some batoning. Grab a few pieces of maple here. I'm just going to use, rectangular wood so that it's all consistent. So it's a more fair comparison. Let's start with this guy. I would say it's still pretty decently sharp, but it's grabbing enough that I think that's a good spot. Let me make sure it's not any sap or anything that's doing it. Yeah. Oh yeah. I could still get it to slice through the paper, but I think that's a pretty good spot for now. So next, I'm going to put a flat grind on this, and then we'll do some testing again. So I have it under the microscope here, and this is the spot where I really put some of the heaviest abuse. And as you can see, there's a little bit of edge chipping and rolling going on along this. Let's see if I can zoom it in a little bit. Try to do this with one hand. Yeah, so let's see if I can get you in focus. About right there. Not quite. Okay, there we go. There's an area with some decent damage to it. So, it held up really well for how much abuse I put it through. I was pounding on it, going against the grain to cut through a few pieces of really hard maple, and that's from some ambrosia maple, which is really hard stuff. So next I'm going to go ahead and put a flat grind on this, and then we'll do some testing with that next. So now I have it back in the sharpening system, this time with the straight configuration here. And we are at 10 degrees exactly. So I'm going to go ahead and put in a 10-degree secondary bevel across it. And then I'll put in a 20-degree micro bevel once that's finished. So I finished sharpening in the micro bevel, taking off the convex. I could feel Waco's tears as I took off a perfectly good convex with a straight edge. But as you can see here, I have this at 10 degrees. I did that to 1100 grit finish. And then the micro bevel, along right here, that I did to 3000 grit finish and 0.5 micron strop, just like with the convex. So the next step will be to test. So here we are with the flat edge, and I'm going to start off and I'm going to go through the same tests that I did on the other knife, and we'll just keep comparing between the two of them and see if there's much of a difference, if I can notice any difference. And I will probably be doing more testing beyond this, but I'm not going to film all of that. There we go. Okay. So I'd say that's still, this is about, so the most taxing thing I would say that I do to the knife is batoning cross grain on this piece of wood. This is the same piece of wood I did with the convex. And I would say where the sharpness this is at is literally where the convex edge was at after just one time through this. Now the other thing is the very first time I went through this with the convex, it took me quite a lot longer. And that could have just been that a knot there. I didn't really notice a knot there though. But one thing I can tell you right now that almost makes me want to not even bother with doing further testing is that the experience of using the knife in this configuration with this edge geometry is way better than I experienced with the convex, which I'm surprised. I was expecting them to be similar, but I actually did expect for this to possibly be a little better because it's now at a little bit of a thinner geometry than the convex was, but there's also still shoulders. So really that tells me the shoulders honestly don't seem to do much. When I was cutting through, just doing slices, it's literally from the same piece of wood that I was cutting between the two, and I felt like I was cutting softwood with this compared to the convex edge. So I can't really explain why this seems to have better retention through the same tests. If I were to guess, I would say it was because this performed more easily with a lot of the tests. Honestly, just shaving wood off didn't really seem to dull either edge. Both of them were able to cut through magazine paper with no problems. It wasn't until I started doing, batoning through this that it really started causing major edge damage. But this I went through 4 times, whereas the convex edge I only did twice. And even after 4 times going through this is still sharper, just slightly, than the convex was. I probably have to do 1 or 2 more of these to get to the point where the convex was when I stopped. So that's really interesting. And I will probably have to do more testing to put this to bed for sure. But I really think that maybe it could just be that this also isn't the correct test. But then that begs the question, what is, and does it really matter? I'm starting to wonder if really the only time where convexes would be superior to this is under high impact. I did chop with this, but the reality is I'm chopping higher up, lower down on the cutting edge, because I'm trying to focus most of the damage in the same area, and so I'm not really using the belly, which would give me a little bit more leverage. But this isn't exactly a chopping knife. This thing's tiny. It's a little puko knife. So I think chopping is where you're going to see a lot, where you're getting a lot of those very extreme lateral forces. But even when I'm batoning, this was often not straight, so it is taking a lot of impact of lateral loads, but it's less impact than if you're chopping. So I am fairly convinced at this point that convexing isn't really worth it for most people, and I think that it's probably a little bit overblown in how good it actually is. But I'd be happy to know from anyone else what your experiences have been, and what your thoughts are on this. I know it's kind of a big point of contention among some knife makers whether or not, V-edge versus a convex is better. But I just have never really seen somebody compare it when they're using a micro bevel. And honestly, for slicing and cutting through things, I just think that this is the better geometry, is what my conclusion is at this point. I might do some more testing, but I think that's where I'm at right now with what I've done thus far. So here's this edge under the microscope. I'm already at the max zoom that I had the other one to at, I think I left it at 2.6. Ignore these white crystals and particles. That's just particulate from the wood that I didn't get cleaned off. But it does have a little bit of edge damage. And if I move it, see if I can do this with one hand. Move it along a bit. It's got a lot of good, clean. Oh, there's a chip. And so, honestly, under the microscope, I would say that it looks about the same as the convex edge. Even if it felt a little better, I'm going to say they're in roughly the same state from what I'm seeing under the microscope. Certainly close enough that it's pretty even. So I'm going to say here then that edge damage wise, they're neck and neck. But the actual feel of the knife, it's how easy it was for me to cut. I'm definitely going to prefer a straight edge. And so I think from now on, bye-bye convex. Never thought I'd say that, but I'm pretty confident at this point.